Cool. So the recording has started. Yes. So for the benefit of people who have joined today and who missed out on yesterday's session, I will quickly brush up what topics we had gone through in 10-15 minutes. So I will request the people who had come yesterday to just bear with me for 15 minutes, and then we'll take it forward from there. Okay, guys. So yeah, so welcome all, and a warm welcome to the people who had joined today and missed out on yesterday's session. So yesterday, guys, basically we learned about uh, why data is so much important in today's business, and what are the challenges that we face around the growing data. The big data term, the buzzword that everybody keeps hearing now and then, and why is data so important, and data is being called as the new oil of the world, right? So you know that the economy, most part of the economy is driven by oil, and data is now becoming more important than oil because it is the raw information or the raw data which can turn into meaningful information and give business insights. So say if you have a business retail shop, there could be some questions in your as a business development officer, or maybe the owner of that business. You might have some questions to answer so that your business can prosper and thrive in the market and have an edge over your competitors. So I mean, so some basic questions, which store. So if you have, say, if you have multiple stores in the around the world or maybe in the country, you might want to know which store among them is the best in sales, right? Which store is not performing up to the mark. Who are our premium customers? So who are our frequent buyers, who keep buying from us? And you can put them in any category, premium customers or say loyal customers, whatever you want. Then which region, which particular part in the world is the most you know what do you call, productive for you guys in terms of sales. And say if you have some tie up with a courier company which will deliver your goods or products to your consumers, so who are my courier partners and who are the ones who are delivering on time and having a good customer interaction. So of sometimes having a good customer interaction also uh, you know uh, counts, and it adds to the customer base and the loyalty that customer gives you. So all that kind of stuff. Then which region is likely to have maximum traffic during holiday seasons? So these kind of questions, I mean, there can be more. These are some of the basic questions as a business person you would like to ask, isn't it? So, but how do we answer this? This answer can only come when you have good amount of data. Okay, so in this case, when you have good amount of purchase history of your customers, right? So uh, there was a use case that we discussed yesterday. So please do go back and check that. We had, sorry, so we had created some, dummy transactions. So these were some dummy transactions that we created. Like each customer has a record of transaction stored in your data warehouse, and based on these insights, you can derive the answers to your questions, like which particular customer is loyal, which particular courier is performing well. For example, if you see here, there is one courier, speed fast, which sorry, first flight, which keeps on delivering defective pieces along with delayed delivery. So such kind of insights we had as a example set we had taken. Then what is a dimension? Okay, so before coming to dimensions, we try to understand two models basically, which is your OLTP system and OLAP system. Okay, so what is your OLTP system? What is your OLAP system? So just to give you a brief, uh, your OLTP systems stand for online transaction processing. This is your database sitting here. So this could be your Oracle, MySQL, Postgres, and all that. And these are mission critical databases. So here you are basically interested in running your business process. That is your day-to-day online processing, day-to-day transactions. That is what you are interested in, right? So this is the place where you will not do any analysis on the data. Okay. You are just interested to keep your business running. That's it. There is an online purchase, you record it. There's a online insurance purchase, you simply record it. You're not going to do any kind of insights on that. Like if you have this data, you're not going to aggregate on, okay, so Kaushik, what was his purchase history over the past few months? Maybe say over the past 6 months, what was the sales that came to me from Kaushik, and say product wise from iPhone mobiles. You won't do that on this particular area here because it is simply meant for your transaction processing. So in order to achieve that, what we do is we forward all this data, we keep the transactions here, and we also transform that particular data in between here through a ETL tool, and we do aggregations based on our requirements and our business cases. That okay, I want aggregation on the sales for this particular customer, for this particular credit, for this particular product. Okay, so those kind of insights I want to aggregate it, and I want to put it into my bigger warehouse, bigger OLAP system where I will do the analysis. So this data warehouse, this is called as a data warehouse. Here all the analysis will happen. So which is why it is called as online analytical processing. And this particular warehouse will be my source for my analytics people, who will derive visualizations, reportings. They'll do reportings based on their cases. The data science team will apply their machine algorithms here to create models and all that. So this we wanted to understand this because there's a difference. The OLTP systems are basically your read write intensive databases. Okay, and so since you won't have to do any analysis here, you need to keep the system running because there are thousands and millions of transactions happening, and you don't want to do analysis here because it will slow down your processing here. So that's why we simply dump all the data here through some ETL process in between. ETL is nothing but you are doing some transformations. As I said, aggregations and normalizations and all that stuff. One good example is, say, if you have, if this is your retail chain, and if you have, it's spread across the world. There's some stores in UK, some in India, Australia, and USA. So obviously, all these transactions will have different currencies as per their country, right? So when you are passing it on to the OLAP system, so there could be one transformation that you want to convert it to a common currency, say a dollar. Okay, so I want all the transactions when I'm doing analysis, I want them converted to dollars here. So that I will not do on online transaction processing because it will slow down this. This is meant only for recording the transactions. So I don't want to touch and hinder anything here. So all those kind of transformations I will do through this in between ETL process, and ETL tools, like Informatica, Talent. You can even do programmatically through Python, Java, and all that. Through that I will do and put it into my OLAP system where I will do the analysis. So that is what is your warehouse. This is called as a data warehouse. And the end users are your analytics team. Okay, so you will never see the analytics team on the side of OLTP side. So you will see always different data sources here, incoming data here, but here it will always be kind of incoming as well as outgoing. Okay, guys. So this is a brief discussion or brushing up I'm doing. We did some more detailing here. We went through the definitions. What is a data warehouse? What is OLTP? What is OLAP? And then what are dimension tables and what are your fact tables? So it will take another half an hour to go in details here. But I gave you an overall superficial, or say you can say a 10,000 feet overview of whatever we had learned yesterday. So request the new folks to just go through the recordings and just come up to speed on this. And feel free to ask me questions. Once you have seen the recording, feel free to ask me questions based on your learning if there is anything. So guys, today we'll start with cloud computing here. Okay, so cloud computing basically. So guys, this course is not about cloud computing. but you need to know what cloud is, and few services on a high level we need to know, because there is a link with Snowflake. Okay. And that we will come to know once we are done with the overview of your cloud computing and some few services. Okay. So yesterday we also, studied the definitions and the concept behind cloud computing. So for the benefit of folks who have joined today, I will just quickly give them one more brief on that as well. So guys, yesterday what we did, we created one analogy. So for a marriage, we just jotted down what are the requirements that we would need for a smooth marriage to function. Okay. So we came out with these points, like we need a hall, we need caterers for food service, then we need decorations, we need transportations for guests, accommodations, we need to print, cards, printing, wedding invitation cards, then dresses, then gifts and all that stuff. So here, the main point of discussing this was that we will not be buying all this stuff. We will be hiring this stuff on rent. And why would we hire them? Because it's a small, yeah, of course, it's a big event, but it's not a long lasting event. It's a 5-day affair or maybe a 3-day affair, depending on the customs, right? And if you go to buy all this, it will be a great, uh, costing issue on your side, right? Then the one more biggest challenge is your maintenance and management, right? For example, if you are managing the caterers, so from what raw materials to what masalas to what kind of rice to what kind of flour, wheat, this, that, you will have to get into all that stuff. But simply you don't do that. You simply go to a caterer, based on your budget. You go to that caterer and say, I want these dishes, I want these items to be there during my marriage ceremony, right? This sweet, this rotis and these curries and these and all that stuff. Rest all is the headache of the caterer. You are simply outsourcing it. So the management is not on you. Okay, so you are basically just hiring and outsourcing that part. And at the time, so if you go and start building all this on your own, the kind of time is unimaginable that you will spend, right? So the marriage that is supposed to happen in a month will happen after 10 years. So there's no point, doing or buying stuff or creating stuff on your own, because we highlighted a few points, like it's a lesser day event and then costing, management and time. So, but why did we go for this analogy? So then we came to a use case of a business model. Okay, say if there's a Flipkart kind of retail chain online, and they will have a huge amount of infrastructure requirement. Correct. So there might be some thousands of servers required. There'll be a lot of storage required. There'll be network connectivity, network devices that they will require, and they will want to host their websites, and then those websites should be highly available in all the regions across the world, across the consumer base they have in the world and all that. So isn't it not similar to what a marriage infrastructure is needed? Of course, bigger than that, but it's a kind of analogy that you can draw. So why not hire, like how we are hiring all this stuff here? So why not hire this and just pay till the time you're using it, right? So so if you want to from scratch, you want to create your infrastructure or build your infrastructure. So these are the bottlenecks, right? There's the time to install your infrastructure and the kind of capacity planning that you need, right? So as a business person, you need to have a vision, right? Like, okay, so I'm starting my business. Down the line from say 2-3 years, at least this will be my capacity for planning which I will need. And you will never do under provisioning. You will always do over provisioning, because you don't want your resources to fall short. So that capacity planning will be an issue. Okay, you will need a proper planning. You will need a good expert people to do your planning there. then you'll have to hire a lot of technical folks to manage all this infra, then your management, and then your capex. Capex is this is all your capex, basically capital expenditure, right? So uh, basically when you're trying to uh, start your business, there's a certain amount of capex required, which is nothing but capital expenditure. So there'll be a huge capital expenditure required to do this on your own, right? So why don't we you know draw some inspiration from this marriage ceremony and simply go and hire this stuff. And we know today that all this stuff, infrastructure and all that, is being provided by some cloud providers, and they are nothing but AWS, Azure, GCP, Alibaba, and so many others. Of course, the famous being the trio AWS, Azure, and GCP. So why don't we go and tell them, okay, we want to hire these many servers, these many storage network devices, do all the stuff for us. Okay, and we will pay you till the time we use it. Okay, all you need is a internet, and just get started. So that is what a high level on what a cloud computing or cloud servicing means on a high level. This is what we discussed yesterday. So I'm not going to repeat these definitions and again. So just go and see the recording once. Okay. So today, okay. So I'll just give you. Let me just give you last analogy. So we discussed what on-premise versus cloud means, right? So on-premise is nothing but your infrastructure installed at your place. So for example, if you see, if you're working on Oracle or, maybe MS SQL, you will have your database server installed somewhere near, right? And within your business premises. And that is where you will connect to it through your client software. But if you see, even on a personal laptop, this is my personal laptop. So I have installed Oracle on this laptop. So I had to download the installer and then install it on my machine. And then my database got created on my machine. And then I am running the queries through the client that I have, SQL developer client that I have on my laptop. Correct? So this is what is in on-premise. It's on my machine. It's within my area. Okay. So, but then cloud provides you with your internet connectivity. You can just have a laptop and get connected to the cloud and use the infrastructure services or the various other platform service or software as a service which cloud provides. Just get connected from anywhere through your laptop. That's it. So we draw an analogy from there, like when you have money in your wallet, that is something called as on-premise, and when you have money kept in your banks, that is something which is called as cloud. So your infrastructure, you can take money as your infrastructure. It's there with you. You're managing it, this and everything. But your infrastructure here in the bank is being managed by the bank. So that is what is the difference between on-premise versus cloud. Okay, guys. So I'll stop here, and any questions, feel free to ask before we proceed. Okay, guys. So I think no questions on there. Let's start with today's topic. So today we are going to look at a use case, basically. Okay, so it's about Netflix. So say this is your user. Okay, so this user is a very big movie buff or web series buff, and he likes to watch Netflix. He has subscribed for Netflix. So looking at from the technical standpoint of view, so there'll be some server which will host the Netflix website, right? So this will be my web hosting server. You can say that. Okay, where when I click on that, so as a user, when I go on the net and say, let's go here. Let me go to Netflix. And as a user, when I go to my Netflix website, this page comes up, right? So this is a website hosted on some server, which is when you do throw this URL on the net, it gives you back this page, right? So this is where that particular server is, right? Then when you go to this server or say this website and you log in and do all that stuff, and then you say want to watch some movie, and you will click on that particular movie or web series and it comes up and you start watching it. So obviously that whole video data, video files and all that, they will have to be somewhere on some storage server, correct? So imagine, so I have drawn only two boxes here. Obviously, this will not be the case. Netflix is a worldwide watched website, right? It's a portal, video portal, watched worldwide, not only in India, correct? So imagine the number of users, guys. Imagine the number of subscriptions Netflix has. Millions of subscriptions it has. People are joining, logging into Netflix and watching their favorite movies and whatever. So imagine the kind of infrastructure that is needed behind here. So as a business person of Netflix, I will have some similar questions which we saw in yesterday for my business growth, right? I will have some kind of similar questions here. Okay, which country is giving me a lot of subscriptions? No doubt it will be India, right? Because we are the most movie loving nation. So which country watches the least? In India also, which particular region watches the most? All that stuff, where did my subscriptions go down? And there'll be some also some forecasting that Netflix will want to do, that in the coming 6 months, how many subscriptions are potentially at risk. Okay, these guys can, go down. These guys might not subscribe back. Maybe on their viewing history, they will go to their viewing history. What was the last time they viewed? So say some person has, not watched anything on Netflix for the past, say 20 days, right? So that might be a potential person who will not want to subscribe in future. So those kind of insights. So they will have a lot of questions for a better business growth and have an edge over their competitors, right? So they have so many, nowadays so many online, they also call it as OTT platforms, right? So there is Amazon Prime, then there is Wood, then there is what, I think, forgot, Lionsgate, I guess. So
Disney Hotstar.
Yes, correct. Disney Hotstar, yes. And this, I think Sony also app. Everybody has an app now. So these are your customers, right? So I want to stay ahead of them. So guys, tell me, if I spend my energy working on this infrastructure here, when will I get time to work on the data? I am simply interested in my users' data. What is my viewing, pattern of my user? What is my, subscriptions? When is my subscription going down? I am just interested in that insights to be created. Okay, so I think this one. So whatever data is coming here on my data warehouse, let's consider this as Netflix data. I am interested to just generate insights here through my analytics team, and I want to make business decisions. I don't have the time and I can take headache of installing the infrastructure and doing management also there, looking after the technical team also. Technical team is not gelling with management team is not gelling with technical team. They have so much of over the moon expectation, all that hassles. So what Netflix did, or not only Netflix, many people are doing, many businesses are doing, but we are taking case of Netflix here. So they have outsourced all this stuff to AWS. So what is this? This is my computing resource, right? Where I will keep my web, where I will host my website basically. This is my compute sources. This is nothing but what? It will have the CPU, this will have RAM, this will have SSD, so many other stuff, right? This is a graphics card, all that stuff. Then this is my storage. So this could be some file system. Obviously, storage will nothing be but a disk only. Disk, it could be a file system. file system kind of a disk with video files and all that stuff. So what is this? This is storage. This is compute and this is storage. And of course, many other stuff is required here. This is not the scope of that, but it is on a high level to understand. We are trying to see what Netflix leverages. So I will go and tell AWS that, guys, I need computing resources, I need storage resources, and apart from that, I need some other stuff also. You guys do it, and we will pay you as long as this particular user is watching my Netflix website or a video, and your server is busy catering to his needs. I will pay you till then. Okay, so that's it. So they went to AWS and said, can you guys do it? And AWS anyway became a cloud provider. So they said, okay, yes, we can do this for you. Okay, so let's go to AWS website. I will need you all to also create, your free accounts on AWS, it's very easy. Just go to AWS console and it's self-explanatory how to create an account there. They will ask to, I think, enter your card details also, but don't worry, they will not charge you. Okay, unless, initially they will not charge you. And if you're not smart enough to how to use the cloud services, then, then you might incur some charges. So for Snowflake, anyway, we don't need a lot of, work to be done on cloud, but I will tell you what all is required. Let me just log in, guys. Okay, so this is how AWS account looks like. Okay, once you create an account, it will ask for a username and login ID kind of details. So this is my login details, and this is a generated automatically generated account ID given by AWS to me, right? So this is how an AWS console looks like. So what Netflix does is Netflix goes and tells AWS, okay, I need a few computing resources, I need storage resources. So Netflix says, okay, I have a services option here, and I have some categories of services. Compute. So these are all the highlighted ones in bold. These are all your services. Okay, machine learning, then your containers and your compute, and you have the storage also, then there is your database also. So you guys might have heard of Redshift also. I don't know, I'm not seeing it here. It must be somewhere. Yeah. Okay, never mind. Wherever it is. So these are the services AWS provides you. So Netflix says, okay, I need computing resources from you, and they will give some estimate. Okay, I need these many compute services. So there are so many options here. See, so they say, okay, we have so many options here. Which one do you want? So they say, okay, we want to choose EC2. Okay. Then they say, okay, what about storage? You have so many options here. So they'll say, okay, we want S3. This stands for Simply Storage Service, and this stands for Elastic Cloud Compute, I think. Okay. So they say, okay, we want. So here AWS says, okay, so this will be your EC2s, as like my service of EC2 will be given to you, where you can host your websites. Okay, so the page which comes up in the background, the processing is being done by the EC2 service of your cloud provider, which is AWS. And then for storage, Netflix has chosen S3. So, okay, my S3 service under the storage services, my S3 service will be given to you. Cool. So as I said, cloud is basically pay as per your needs I mean, pay till the time you use, pay as per your usage. And then once it's done, you're not using it anymore, you don't have to pay a single penny. That's what the cloud billing model is, correct? Of course, there are some upfront charges services also where, whether you use, this much of service or that much of service doesn't matter. You will have to pay an upfront fees. There are some services that like that also. But overall, on a general term, if you see, it is mostly pay as per use model, right? So imagine here, say in the daytime when everybody is working, there is very less traffic. There is very less traffic on on Netflix. Everybody is busy on weekdays. They're not watching, they're doing their work, and there's a lot of very less traffic coming in. So my AWS is smart enough to provision my resources as per the traffic. Okay. So if you see the problem here, I had to do capacity planning and I had to mention, okay, guys, I need 1,000 servers for the next 6 months. And say, God forbid, some planning goes down, goes wrong, and you just needed 500 servers. So what about the rest of 500? It's a huge loss. Or maybe say I wanted 1,000, but actually you needed 5,000. So already there was so much time to install and connect all this infra together. Now you need more 4,000. So again, imagine the kind of time you will need to, install and connect it to the existing infrastructure, right? So your business will have to be stopped at some point in time. So, but all this headache is given to AWS now. So, Netflix is saying during these hours, if my traffic is less, give me only this many computing resources, and say during the evening times when people come back from offices, schools, colleges, and suddenly my traffic increases by leaps and bounds at the night. So I need more provisioning of the processing power. So AWS will automatically scale up the EC2 machines. Okay. And it should be highly available. Say I have now during the night or evening time, whenever the traffic is huge, I have so many users getting connected here. So many users getting connected. So they're all logging. They're all logging into this EC2 machines. So it should not be that only one EC2 or two EC2s are getting overburdened. So they will get crashed, and everybody will get a message unable to view. Sorry for the inconvenience, all that. So there has to be a high availability also, that no matter what the number of concurrent users being, logging in to my system, AWS is the responsible system, so that there is a high availability of my resources to them. Okay. And then I have the S3. Apart from that, I have S3 storing all my video formats of all my video files. So they should be in compatible formats to both TV, to your phones, to your iPads, whatever device you're logging in, they should be compatible with those formats. Then, so this should be able to process any kind of data, whether it is structured, unstructured, semi-structured, don't mind. Don't care about that. Okay. And the other stuff is, if I have a S3 bucket here, say in some region in Mumbai, so a person who wants to access it from, say, say what, maybe China, there will be a lot of network, delay connecting to this server here in this region. So this particular file should also be available near to that some region near China. So that is also kind of, it's called as caching. It's not exactly caching, but understand from the concept of caching, it's basically, copying that file somewhere. So, this is not a cloud detailing class, but I'm trying to just give you an idea, overall idea. So the cloud is able to firstly, you should be able to, on demand, go and get your services started. What does it mean? So I have created this account here on AWS. I go to services. Okay, I go to EC2. And I should be able to configure stuff and create my instance, launch instance. Okay. When I click this launch instance, so there are some pre-built templates. These are also called as Amazon machine images. Okay, I mean, this is not nothing to do with our course. I'm just giving you for your understanding and how we connect it with Snowflake later on. So this will give you some pre-built templates. Okay, Linux machines, Windows machines, whatever Fedora flavor, Red Hat flavor, and all that stuff. So see, this is with no Windows machine also. So you select it as per your need and you're ready to start. So this will spin up EC2 machine for you. So EC2 is nothing but a machine with your computing power, which is RAM, CPU, and processing power and all that. Okay. So see, it's so easy. It's on demand. You go, you just need internet connectivity. You go and launch it, and you are ready to start. So it should be on demand. Then it should be highly available. So all that, and it should be scalable at any point in time. So say at 9 p.m., I have a huge traffic. So my AWS should be able to scale it up within minutes. Okay, I cannot wait for say 1 day. Okay, I need more 1,000 servers immediately. I cannot wait till tomorrow. I have I need it in a few minutes. So that and once that time is over and you come back to your normal timings of say morning where there's a very big dip in the traffic. So I don't want to use all of them, right, which I procured yesterday or provisioned yesterday. I want them to be released. So that also scaling down also should be available from AWS side. So all those hassles which we had on the on-premise is removed due to the cloud. Okay, and what is the services which Netflix has asked to for its purpose? If we just discussed. Okay, so Netflix will take for computing power, it will take as your Amazon EC2, and for storage, it will be your Amazon S3. And Netflix uses services of AWS. So this is a typical use case or a diagram. And what is EC2, guys? It's nothing but kind of a basic computer. Okay. And it will have your CPUs, operating systems, it will have an SSD drive, network cards, firewall security, RAM, all this, a normal computer. And as I showed you on the console, there are typical Amazon machine images provided to you. So if you want a Linux machine, that is, a Linux operating system installed on that also you can choose. If you want Windows, you can choose. Later on, when you do the configurations, you can also choose the amount of memory you want, the cores you want, the CPU cores. That also you can choose as when you go and configure for EC2 service, right? So this is nothing but a computer being provided to you in terms of compute power, which is an Amazon EC2. So there are other services under compute power, but Netflix takes the service of EC2. What is your S3? It is an unlimited storage bucket. And as you can see, it will have any kind of data it can store: video, flat files, audio, binary data, pictures, videos, whatever. So that it's nothing but kind of a drive. And the main advantage of S3 is that it is highly available and it is highly durable. So Amazon says you have 99.99% availability on S3. That's what Amazon says. So guys, what does Netflix use in the background? EC2 machines where your web hosting is done, and when you click on the website, your website comes up. That all computing power is being leveraged through EC2 service, and all the video files of or the web series and all that movies, they're all kept in S3. This is how Netflix works behind the scenes. Okay. Cool. So we are done with a basic overview of what cloud service that we need to know. So right now we have just seen two services: compute and storage, EC2 and S3. Okay, and why we have studied or tried to learn about this, we will see in a few moments. Okay, when we start Snowflake. So now we are about to start Snowflake. Any questions still here for this particular topic on cloud? Okay, guys. So I'll move forward. Cool. So let's start now with Snowflake. This is why you all have joined this class, right? Everybody of you, one of you wants to learn Snowflake. What is Snowflake? What is it all about? So all that we had studied till now was a brief, a ground that we were preparing, for Snowflake, to understand Snowflake on a better way. So all that we learned about data warehousing, about cloud computing, what is cloud, what are different kinds of services, that is all going to lay the ground to understand Snowflake. Okay. So Snowflake, guys, is a cloud data warehouse. Okay. So this side here, this is your Snowflake, a data warehouse, but this is on cloud. So let me open up a different paint worksheet here and say this is your cloud. And my Snowflake is in the cloud. It's a cloud data warehouse, basically. This is my Snowflake. So till now, we have seen what a data warehouse is. The cloud data warehouse is. So we know what a cloud, we know what a data warehouse is. So the only thing when you say cloud data warehouse is that you don't need to install it on your machines, like how I went to AWS console, right? And I'm ready to start, ready to take care of, use the services which Amazon provides. You just need to go to cloud. Some website will be there. You need to go to there, register yourself, and you're ready to use Snowflake. That's it. That's why it's in the cloud. And that's why when we saw that diagram also in the PPT, let me go back there. See this person here. So he has connected to internet, to some cloud service provider here, and it's got connected here, and that's it. So for my laptop, I have not installed anything on my laptop. I have just connected to the cloud. Okay, so Snowflake is basically a cloud data warehouse. It was founded in 2012 in San Mateo, California. Okay, so these folks, Benoit, Thierry, Marcin, these are the founders of Snowflake. These were all data warehouse experts, and some of them were also working earlier in Oracle Corporation as data architects, data warehouse architects. Okay, so they came out of Oracle and they built cloud data warehouse for cloud. As I said, it is built from scratch and it is only for cloud, which means if you like how I've installed Oracle here on my machine, okay, uh, you don't need to do that. You just need to log in and you can get started. So it was termed as the cool vendor in Gartner's Magic Quadrant and won first place in 2015. And it got the GA status, that is general availability, which means nothing but you are ready to start in the market in 2015. Then it is very easy to learn because the native support is of SQL. So how we have these databases, right? Oracle, Postgres, MySQL, all that. So they all have the background native language SQL, right? So you fire your queries and get your data, whatever you need out of that. So similar to that, Snowflake also has a native support in SQL. So it's very easy to learn. So anybody who has worked on SQL, who has a good knowledge of SQL and database concepts, so they are good to start and they should be easily leveraging that those particular skills acquired over the years to learn Snowflake and have an advanced technology in your kitty. Okay, let's get back. Today, all kinds of businesses, whether it is retail, pharma, finance, and any other major enterprises, they're all migrating to Snowflake. I mean, it's not that 100% everybody is migrating to Snowflake, but Snowflake is the most popular cloud data warehouse today. And why it is popular, you will get to know in few minutes. Okay. So there are so many databases. Even Amazon provides so many database services, right? When we go back to the services here, so you must have seen a service category here, databases. See, there's so many they also provide here. So this RDS, it's nothing but your relational data services, database services. So here, all the relational databases, basically your, Amazon, your MS SQL, Postgres, Oracle, those kind of services or databases can be hosted here. So if I just click that, okay, and if I say create database here, so it will ask you to choose standard. Of course, this is not part of, and we don't need this. So it will give you so many options, right? Amazon Aurora. So this is Amazon's own database. They have created MySQL, MariaDB, Postgres, Oracle, Microsoft SQL Server. So this is all your RDS category, relational databases services. So what is relational databases services? The databases that store your data in forms of rows and columns. That is nothing but relational database services. So there are a lot of available cloud data warehouses, cloud database services. Even this is just AWS. There is Google also. There is Azure also. So they have their own database services which they provide. One more famous is Amazon Redshift. So many other options are there, but Snowflake is the most popular today. So it's a complete SQL database, guys. Just as I just mentioned, the native support is in SQL. So whatever you can do in SQL, you can do all that on Snowflake as well. So the core SQL, the basic SQL, right, where you have your simple DDL statements. DDL statements are nothing but your data definition language, right, where you can create tables, create views, anything to do with create or alter. That's that object level creation or object level changes. That is your DDL, right? The support for information schema. We'll see what schema, information schema and all that is. Then data loading. You can do your data loading through this. There's a copy command that you can do it. So you can have your data residing in S3 bucket or any other data source, and you can get it into Snowflake. There's full table support for DML, that is data manipulation language, merge, update, delete, inserts, all that, and analytical SQL, which is very important, right? Windowing functions like lead, lag, rank, all this, is required basically when you do reporting. So if anybody is working in the BI side here, they will know this because these queries are very important. So we'll see this as well. Then SQL is simple select queries, right? It doesn't provide you with I mean, it does provide you, but it doesn't provide you with programmatic kind of steps. Like, okay, this is statement one, this is statement two, do this after statement three, do a if else condition, do a loop after that. All that procedural programmatic, it does not provide. So you have to overcome that. You have UDFs, user defined functions, stored procedures, so that you can leverage the capabilities of decision making through if and else, then your for loops, and all that stuff. So you have that as well. So why the name Snowflake, guys? Because one of the founders apparently was a sports lover, so winter sports lover to be precise, and which is why they called it Snowflake. So just a fun fact. This is a slightly older slide, guys. I don't normally update it because it doesn't matter much. It simply says the kind of growth Snowflake has been doing. It's 400 plus employees when this slide was created, but it's of course increased. And they had to start with their headquarters in these regions in Australia, UK, and now they are spread across so many places. Cool. So this is a brief history of Snowflake. Okay. And we already know it is basically a cloud data warehouse. And to understand in a very general terms or layman terms, it's nothing but it's storing data. That's, I mean, ultimately, the bottom line is that, right? It's storing something. So Snowflake basically stores something. So it is a storage kind of service, but there's more to it. And we'll see, what all more it brings on the table and which is why it is so popular also. Okay, let's go back to the slides. So what is Snowflake, guys? We just discussed. You see this storage area here, it's in the cloud. So it is basically built for the cloud and it is a SQL data warehouse. It is built explicitly for the cloud and it is delivered as a service. So like how Amazon has so many services, compute, databases, storage, machine learning, all that. So so those services, are all your so there are three types of services which cloud provides, right? Infrastructure as a service, platform as a service, and software as a service. So this we discussed yesterday. So the folks who missed yesterday's class can go have a look at that. So cloud warehouse, which is Snowflake, that is provided as the software as a service. Okay. So what is the vision of Snowflake? It should provide all users anytime, anywhere insights so they can make actionable decisions based on data. So when we started the class, we started with what the importance of data itself, the kind of business insights you can generate out of it. This particular vision is stating that anytime you should be able to log in here, run your queries or run your reporting, and you should be able to make actionable decisions based on your outcome of the result of the queries and all that. So once you are in cloud, as we saw the use case of Netflix, Netflix says my user should not get any issue in viewing experience. The streaming of my videos or web series should be very seamless and very clean for my users. So basically, that is what it means here. So any user of Snowflake should be able to log in and he should be ready to use the data. That's what it says. There should not be no downtime. For example, you're all working, most of you, I hope. Every now and then you will get a mail, okay, monthly mail. Okay, so today for 2 hours there'll be a downtime. On weekend there'll be a downtime. There's a patching going on. There's an upgrade going on, and all that stuff. So all that hassles I don't want. It should be always readily available, and I should be able to log in, use my data warehouse. That's it. So what is the solution for that? A next generation data warehouse built from the ground up for the cloud and for today's data analytics. So your Snowflake is the solution for this. And it's a next generation data warehouse built from scratch. Cool. So see, everywhere the importance of the philosophy boils down to the usage of data. So what is Snowflake's mission? Enable every organization to be data driven. Okay. So there's just a small example or a story. So there was a microwave manufacturer called June, okay, June. So they, built smart microwave ovens, smart microwave ovens like smart TVs and all, where you have so many apps built in and it does so much of automation for you. So they collaborated with Alexa, which is a voice assistant of Amazon, right? So they collaborated with it and they created a smart microwave, and they were selling this on Amazon website, Amazon, online retail that we all shop on. So Amazon has had the data of this manufacturer, June. Okay, and they saw all that, like how they are manufacturing it and all that. And then they came up with their own microwave version, and which was half the price of June. And they wiped them out of market. So see the kind of insights data gives you. So if you guys are interested to, go and search Let me show it to you. Okay, so just type this and how how Amazon was Amazon became its competitor. Just go to this page here. Okay, Amazon's playbook for killing competition. So, but why was this possible? This was possible because Amazon had access to its data, and today whatever sellers are there on Amazon, you will have to give your data to Amazon. Because people don't have that, and Amazon has so much of infrastructure behind its back to host such kind of online retailer mechanism as a business. Not everyone can do, right? So that is the advantage of data. See, just a year later, Amazon launched their own smart oven, which had all the features of June, including Wi-Fi connectivity, Alexa integration. June was selling their ovens for $500, while Amazon cost 250, almost half, isn't it? So this is all possible due to data, right? Okay, let's get back. So yeah, so what is Snowflake's mission? It enables every organization to be data driven. Okay, enables organization to bring together all of their business data. Okay, so today, if you see on the on-premises or the traditional databases, so there will be so many different departments in an organization, right? You will have what? You will have finance, you will have sales, you will have CRM, you will have HR, you will have employee. So many departments, and these are all in silos, separate databases or separate data marts. This could be in some other region, this could be in some other region. So if they have to interact together, say maybe my sales, this is my sales, suppose. Okay, this is my sales, and it needs some data from the finance person or the finance database. So imagine the kind of time it takes to draw data out of here and give data back to them and all that stuff, because these are all in silos. So that is what Snowflake overcomes. It says enable organization to bring together all of their business data together. Then accelerate analytics for any scale of data, workload, user, and application. Okay. So here, if we go back again to the traditional databases, here, if you remember when we discussed this, we said we will not do any analytical processing here, right? Because why? I don't want to hinder my, online transaction processing. So I will, put all my data here somewhere, in some bigger storage provider like Teradata or Hexadata and all that. Okay. So Amazon says, the Snowflake says, doesn't matter what kind of data you have. And today data is growing. It's growing by unimaginable, uh, you know, uh, thought process. If you cannot think about it, it's very difficult to imagine the kind of growth in data. So it says it doesn't matter what amount of data, less, huge, whatever. My analytics should not suffer. Okay, so my analytics should be able to scale for any kind of data, any workload, any user, number of users, concurrent users, and any application. And in a cloud service that enables customers to focus on using their data instead of managing infrastructure. Here, my Netflix is the business folks here are not exposed to all this management here. This management is done by AWS itself. Okay, so Snowflake similarly says so imagine this is Snowflake. You are a database developer and whoever you are, business analyst or a QA, whoever. You just need to log into my Snowflake. Imagine Snowflake is here and just do your work. don't need to manage your computing resources, your storage, and all that stuff. Okay, of course you need to manage. It is not entirely true, but it is might be 10%. Okay, not much. So that is why it says minimal management. This is important. That enables customers to focus using their data instead of managing infrastructure. Right. So you don't have to manage your infrastructure as such. Instead, focus on the data and take actionable decisions based on it. So what is the differentiating technology Snowflake comes up with? Okay, so this is not very uh, specific to Snowflake. Many other cloud data warehouses also provide this stuff. Okay, but yes, so single place of for data, whether it is structured or semi-structured. In a typical Oracle, uh, of course, I won't say that nowadays every traditional database also, provides you support with semi-structured data as well, which is your JSON and all that stuff, right? JSON, if you've heard of JSON, XML, which is not structured properly, it's a semi-structured data, right? So that kind of support on a single place. Then instant unlimited scalability. So since this is in cloud, and we saw the use case of Netflix, the scalability of computing resource and storage should be, whether it is up or down, whether you're scaling it up, scaling it or down, it should be instant and it should be unlimited, right? I mean, AWS should not tell me, okay, Netflix, sorry, you cannot go beyond 5,000 servers. It's your headache. Okay. And once I have scaled it up, it should not tell me, okay, I have given you 500,000, sorry, 5,000 servers. I will not scale it down. No, it should be instant. Then there's a minimal management. Okay. And instant live data sharing. So again, when your data is in silos, and silos means separate places. And you have so much of different data sources here. So when you want to share data amongst yourself, say UK and India wants to share some data between them, the retail business offices want to share the data. So imagine the kind of processing they need to put in between, right? So say this is my India data. I will generate some files out of it. Whatever files I need, I will generate so many files here. It will go to some server, some unique server maybe. Sorry. Okay, so say this is my Unix server here somewhere. I will generate a lot of data files here, here, here. These are files. And then it will go to my UK database or UK team. So imagine the kind of infrastructure also, the kind of time also, the kind of coding, processing required, connectivity, so many things are here. So this will take time. So that's what Snowflake says, that it should be instant. Once my India team wants to access my UK data, it should be instant. I should be able to access it instantly, and vice versa. So that is what it says, instant live data sharing. Okay, so now coming to the most important part, and you can say more technical part here. We will now see Snowflake's unique architecture. Very important topic. Even in your interviews, the first set of questions is from the architecture area. So this is very important. Yeah.
This is wicked. Before
Yes,
going
sir.
to architecture, I have a doubt.
Yes.
Can I interrupt?
Yes, please.
Okay. Can you go to that paint you have created for the bucket, the S3?
The PPT?
Just to share, not the PPT, the paint you have given for that S3 bucket, right?
Yeah.
Okay, maybe.
This one?
Yes, this one. Okay. My doubt is that, see, for example, I have a company that is hosted on a cloud, and I have a Snowflake also. So my users are uploading the data. So Now the data comes and sits in the S3. S3 is also a database, right? Is a kind of bucket, or it will go directly from EC2 to my Snowflake's DB. So just I want to understand, Snowflake is just an OLAP or OLTAP. Just I want to understand.
Okay, just a minute.
You got it right?
Yes, I got it. So firstly, S3 is not a database. Okay. S3
Okay.
is a storage. It's a disk. It's
Okay.
kind of a hard disk. Okay. So I have created, so S3 has a terminology called buckets. So we are going to see all this in detail because this will be required. Okay. So I was just giving you an overview of this. So S3 here, when you go to S3 services, you need to create a bucket. And this bucket, you can draw analogy from a folder. It's a folder basically. Okay, this folder. And under this folder, this is my bucket here. This is my folder, you can say. And under this, you can create folders and you can even upload your files. Add files here. You can upload your files from here. Okay, so this is your, as I said, S3 can store any kind of, kind of data format, video, audio. You can upload movies also here. So all your Netflix audio files, video files are all here on S3. Cool. So your question is, so firstly, I wanted to clarify it's not a database. Okay.
Okay.
So the other thing is, now imagine this is Snowflake instead of Netflix. And you are saying, when I say my finance data, okay, when I store my finance data in Snowflake, so where does it get stored behind the scenes? Is that
it will come from S3 or how it is?
Okay, very good question. So that will be answered in the subsequent flight. So is it okay if I come to that in some
Okay.
time?
Yeah, it's okay. It's okay.
Okay, good. So see, what I like about the question is that, you people have started to think. Okay, so because you know that Snowflake is on cloud, it's a cloud data warehouse. So now when I gave you the use case of Netflix, now you have started to think, okay, behind the scenes, where is the data getting stored in Snowflake? So that's good. So you're on the right lines and we will be uncovering that in some time.
Okay.
Cool. So moving forward, just park your question, Venkat, for some time and we will definitely answer that.
Sure.
So, okay. So let's move on. Before moving on to your architecture, let's just see a typical data pipeline, guys. What is a typical data pipeline? It's nothing but, this is a typical data pipeline, right? This is a typical data pipeline, this whole stuff here. You will have some data sources from different, databases or flat files, or this could be any source here coming from mobiles, from anywhere, any kind of data. It will go to your database. You will have an ETL in between, and it will go to your data warehouse, and end users will be your analytics team. A typical data warehouse. So there's no difference here as far as Snowflake is concerned. So this is your data sources, various data sources, OLTP databases, enterprise, this, that. Then you will have an ETL layer in between, your Matillion, Informatica, ETL, Fivetran, whatever you use. You do your transformations and all your data is dumped into Snowflake. Okay, it's dumped into Snowflake. And at the end, there are your data consumers who will use the dumped data here and they will do their activities as per their requirement, reporting, analysis, real-time analytics, whatever, depending on their requirements. So this Snowflake area here is our storage area, and it can offer you a wide variety of operations. So it can act as a data warehouse also, which means it will have huge storage availability. Because yesterday we learned that compared to OLTP, OLAP requires a lot of storage because it stores historical data as well. So from that lines, it serves as a data warehouse also. It serves as a data lake also. What is a data lake? If anybody knows, a data lake is nothing but the different kind of data that you just go and dump. You don't process anything. There is no schema as such associated to that data. So for example, if there's a data warehouse like Teradata or Exadata, whatever, so you will have some schema in that, right? Some structure. Okay, so they have to be stored in form of tables. There'll be a user associated to it. There'll be a schema associated to all that stuff. So data lake is schema-less. You can dump your files. You can dump your relational data. You can dump your JSON data or any kind of data, structured, semi-structured, unstructured. That is what data lake means on a high level, and that also Snowflake can give you that capability. Then data engineering, where you are processing your data. So data engineering is nothing but the data that you have here, you're processing it. So this ETL layer here, that can also be done within Snowflake through the use of your stored procedures, functions. You can do that programmatically. Data exchange, we just talked about instant data sharing, right? So if my sales team wants to access finance team's data and vice versa, that data exchange is possible. And it can be connected to data applications, different data applications. Then data science. So basically, data science is what you're trying to. That is where you are trying to forecast and bring about your recommendation systems, and based on the machine learning algorithms that you apply, you create models here. So that is all the work of data science team. Okay, so that also is possible on Snowflake. And here, if you see these three things, AWS, this is AWS in the middle, Google, GCP, then this is your Azure. So this means my Snowflake is basically hosted on three cloud providers. This is my Snowflake. So then this is my cloud. So my Snowflake is actually hosted on three major cloud providers as of today: AWS, Azure, GCP, Google, which means it is basically leveraging the services of these cloud players. Okay, so behind the scenes, it is using the compute power of one of these clouds. So for simplicity, let's consider that this is what we are talking about, an AWS hosted Snowflake. Okay, so for computational needs, it is taking the services of AWS. For storage needs, it is taking the help of AWS services. Okay, so on the front end, when you log into Snowflake, it shows you Snowflake interface, but behind the scenes, all that is being used is of cloud, which is why you will see in the diagram here that it is hosted on clouds, either of these, either GCP, AWS, Azure. So it is not a cloud provider, guys. It is important to understand it. You cannot go to Snowflake and say you will not see some interface like, okay, this is Snowflake and this is the services Snowflake provides. No, this is what a cloud provider provides, services. Okay, so under this there will be some software as a service, something which is software as a service, right? So that is what Snowflake is. It is basically a service provided, and which is as a software. And behind the scenes, it is leveraging the computing power, storage power of the cloud that it is hosted on. Any doubt in this? Did you understand what a cloud provider and what a cloud data warehouse is now? Snowflake is a cloud data warehouse. AWS is a cloud provider. Any doubts in this?
Maybe Abdul, that real-time data processing in architecture where it will cover actually. You shared actually data engineering, like big data via Kafka, right?
Yeah. So that will be part of Snowpipe. Snowpipe is a topic. Okay. There you will see how that real-time processing happens.
Okay.
Let me quickly open the course. Okay. So you see this Snowflake continuous data pipelines. So this snow pipe, continuous stream
Yeah,
data. Yeah.
yeah, just I'm asking that in architecture, which umbrella it will fall. Actually, you have shown no data engineering. That means you will write
Yeah,
some
yeah, yeah.
codes,
Okay. Yeah, yeah. So
data
that
like
is,
just I'm asking.
yes, yes. So that is under data engineering.
Okay.
Okay. So, so guys, as I said, Snowflake is a cloud data warehouse, which we just studied, and it basically is hosted on either of these three clouds, uh, GCP, Azure, AWS. So behind the scenes, basically it is leveraging the services of these clouds only behind the scenes. Okay, let's skip this as of now. Okay. So let's now talk about the architecture in a bit. Yeah.
Abdul, I have a question.
Yes, yes.
Yeah, Abdul, you see, right, this Snowflake will utilize AWS services and infrastructure processing infrastructure, right? But there are different types of AMI specific for external SaaS providers such as Snowflake and as other CRM, Salesforce, etc. Is there any specific AMI defined by Snowflake? Okay, if you want to use the Snowflake on AWS, you have to have the EC2 instance of this AMI. Is there any template of AMI, or community AMI, or AWS AMI mentioned delivered by Snowflake to have the instance EC2 instance provision?
Okay. So that is Seva, right?
Yeah.
Okay. So guys, so what Seva is asking here is that so Snowflake, if it wants to use the compute power of EC2 as a service, and when we launch an instance here, as I showed you some time back, when we launch an instance, so here, Amazon gives you a lot of AMIs, right? A template that you want a Red Hat, you want a uh, Windows operating system and so on. So to answer you, Siva, so that is what he's asking, which EC2 kind of AMI does Snowflake procures from AWS? That's what he's asking. So to answer your question, Siva, Snowflake hides that from you. Okay. As a Snowflake user, you will not be able to know what kind of EC2s it is procuring behind the scenes. But if you are a cloud engineer somewhere who is actually that architect of Snowflake, working for Snowflake, and somebody working in AWS, they will know all that. So we as users, we don't know what.
Yeah, but I am the one who had to pay to AWS, right?
Yes. So let's. We will be discussing the pricing model also in the coming time. Okay. So it is basically when you are talking about paying, you are not paying to AWS, you're paying to Snowflake. So you will have to adhere to the rate card of Snowflake. This is my rate card, okay, for Snowflake. You are not going to pay to AWS or Azure or GCP. Got it?
Okay, so, got it now. Maybe, yeah.
Whether you use EC2 here behind the scenes, EBS or your S3 or whatever you use, right? As a end user here who wants to take Snowflake as a service, doesn't matter. Snowflake says, this is my card, this is my slab, you have to pay accordingly. That's it.
Okay, maybe Snowflake will pay back to AWS, but okay.
Yes.
So because
yes.
as organization, right? Already I will be using AWS infrastructures for other my projects, right? Not only Snowflake will be the application of data warehouse. Data warehouse will be one of the area that a company will be working on. There will be hundreds, right? So for those cases, I will be using AWS. Right. Then I have to already I will be paying money for a lot of instances that I AWS provision for me for my usage. Right.
Yes.
So in this case, you mean to say we have to pay separately for Snowflake.
Absolutely.
For even for the AWS, what we use.
So when you are using AWS, you're using some other service, right? So for say, you're using S3 for some other purpose, or say your EC2 for some other purpose. So you are not using it for Snowflake purpose, right?
Yeah, it is
So-
fine. But I see, if we say as an organization, I will not be using a single instance. I will provision a huge VPC, right? In the VPC, I may have a couple of instances available for me to launch my Snowflake service. But you are saying now that that option will be hidden by Snowflake. That is what you mean to say, right?
So
That the Snowflake
tell me
will not
one
give the
thing.
option to us.
Okay, so tell me one thing. Cloud, any cloud, whether it is AWS, okay, let's take AWS. So when you say I want to use your EC2 or your storage or say your database, okay. So your EC2 on EC2 somewhere on EC2 your database will be hosted, right?
Yeah.
Right. So will you say, okay, I am already paying for EC2. Why should I pay for your database?
Yeah. Right.
So will
Already
you
I am
say
paying.
that?
Yeah. For example, in my VPC, I have 100 instances, right?
Right.
It is easy for me to make use of the existing instances, right? To install or provision my Snowflake services, right? In the existing one of my EC2 instances in my VPC.
Okay. So this is your VPC here. Okay, this is your VPC. This is your instances of EC2s. Okay, so many EC2s here.
Yeah.
Okay, as per your organization need. Let's forget Snowflake. Let's forget Snowflake as of now. So you are saying you're paying already for these instances. They are running, right?
Yes.
Now I want to leverage RDS also. There is a RDS, say Oracle. Okay. You want to install it on some already running
existing EC2 instance.
Correct. So will AWS say, okay, you are paying to me already for this running machine. You don't need to pay me for this RDS. Will AWS say that to you?
Yes.
No, I'm asking whether AWS give that facility to you.
No, I think AWS will give if we have, or else they may ask to add a new instance in existing VPC.
No, don't think. AWS has a proper billing model. Okay, we are not going to some shop and bargaining stuff. Okay, so
I'm not talking about bargaining. So I'm asking you, for example, I wanted this Snowflake to be provisioned into my VPC.
Correct.
Right. Is it any possibility? Is it Snowflake allow me to do that? No. Right.
So Snowflake is something outside AWS. It's not an AWS service.
Yeah, I understand. Okay.
Okay, it's not an AWS service because it is hosted on 3 clouds here, right? It can be, it can be hosted on. It depends on the when you are registering for Snowflake, right? When we will create our account in Snowflake, you will see they will give you option of choosing the cloud provider.
Oh.
Right. So this is a service, software as a service. So you have to pay for that service. Okay. So behind the scenes management, all the management, that headache will be taken by Snowflake. That's what they say. You don't have to worry about what cloud services we are leveraging, what storage we are leveraging. You don't worry about it at all. That's what they say.
They will give the option. Okay, you want to go with the AWS or Azure or cloud, whatever you want to choose. Only
exactly.
You don't have this. That's it.
Exactly. Okay. But to answer your question on a broader discussion, so when you buy or say or procure any service from AWS or any cloud for that matter, you have to pay for each and every service for that.
Yeah. I understand that. For example, if you see long-term commitment, if you see AWS pricing model, what we have been getting from our customers, right? Yeah. If you have this many instances for this many years, if you hire this many instances of this many AMIs for this many years, our pricing is dedicated instances. Our pricing is even half of the amount that we have to pay for when compared to on demand.
Absolutely. So
yeah, So as organization will try to save the cost, the minimal
Saving.
savings, right? So they usually mostly what I believe is they mostly go for the long-term contract, only 2 years. So I will use this many instance for this many years, right? In those cases, I would have tried Redshift. That is not working for me. So what I will do, okay, then let's drop the Redshift. We will try Snowflake in the same instances where we were using the Redshift services. That is what my question is.
Absolutely. So as I said in the beginning, so cloud is basically pay as use model. But there I mentioned a disclaimer that there could be some services which will say, okay, give me upfront money, right?
Yeah, that is
Yeah.
the cloud. If you see AWS payment method, right? There are different classes on demand or reserved capacity, right?
Yes,
No
yes,
matter I
yes.
use or not, if I reserve for 1 year, I will get 50% of the discount when it comes to the on-demand.
So that is
But
there in Snowflake also.
uh,
Okay, so there is a pricing, I mean, there is a topic pricing model of Snowflake. So there you will see those options as well. I mean, on demand also and pre-purchase also.
okay, yeah, I just want to imagine. Sorry, conclude. Think about how the AWS Snowflake work on the existing AWS infrastructure. So as you
Absolutely.
said, yeah, as you said, that is not possible.
I mean, you want to
Yeah.
see behind the scenes what it is using?
Yeah, we don't have
Exactly.
control. Yeah, we don't have a control on Snowflake where in which is EC2 services, how
Yeah.
where what is the subnet. We cannot say anything in terms of Snowflake. That is what I
Absolutely.
understand from you now. Yeah.
Absolutely. So once we go back up, I mean, go into the architecture, and after architecture, that will become more clearer to you. Okay.
Okay. Thank you.
Because I mean, I can answer that right now, but let me just go to the architecture first, and then from there I will correlate with AWS. Once I explain the architecture, right, I will correlate what you are saying. So what guys, what Siva is asking is basically, so like we just now learned that Snowflake can be hosted on either of these three clouds, either AWS, Azure, and GCP. Okay, so for our class purpose, we will be considering AWS as the hosting cloud service provider. So what Siva is saying, if suppose my computing power for Snowflake behind the scenes, it is leveraging from EC2 services. So can I go and see on AWS, okay, which EC2 that particular Snowflake instance has leveraged, or which particular storage AWS has leveraged. That is what Siva is trying to ask. Correct, Siva?
Yeah. Yes.
Yeah, right. So I will answer that question, but to answer you directly, I will explain also later. But directly, the answer is no to this.
Yeah, I got it now. So you understand, right, Abdul, what we are coming, because as an organization, I will be having a couple of instances ideal, which is
Yes.
unused or which I will be planning to use in the future, right? So if I say I wanted to try on the Snowflake, I don't want to pay for the AWS. So I only wanted to use as Snowflake alone using the existing AWS infrastructure.
Yes.
So that that
As
is
far as Snowflake pricing model is concerned, they have their own billing model. You don't have to pay anything to AWS. Now, how they share the rates, the incoming money to Snowflake, how they share with AWS is up to them. I mean, we don't have a control, or neither do
yeah.
we know what is the contract between these guys. I mean, of course, people who are internally working for Snowflake and AWS, they will know about it. But we as a user, we don't know that. We are not exposed to that area.
Got it.
Okay.
Got it.
And don't worry, Snowflake pricing model is very fair and very transparent, and it is very you can do a research on that. It is very fair, and it is very what do you say, economical, and it gives you a lot of options to how to save cost and how to be economical and all that stuff. So once we come to the pricing model, that I hope that all questions will be clarified at that time.
Yeah.
Okay, but to answer your question, Snowflake as a service, you have to pay for it. Okay, and Snowflake can be hosted on various cloud providers, which is AWS, Azure, GCP. Behind the scenes, Snowflake is using all the service power of your cloud provider, and you are not exposed to it as a Snowflake user. You're not exposed to behind the scenes stuff, and you don't have to pay to them as well. Whatever you will pay is to pay to Snowflake. Okay. So for example, I am Snowflake. Okay. Tamil Bhumi is AWS. Whatever you will pay. So sorry, I am AWS. Tamil Bhumi is Snowflake. Whatever you will pay is to Tamil Bhumi, that is Snowflake. You pay them like 10 rupees, 50 rupees, 60 rupees, up to you. It's not my concern. So they will have a contract with me, and that which will not be exposed to you. Correct? Understood? Okay.
Yeah, got it. Got it.
Okay. Thanks, Siva. Thanks for asking. I mean, others will also benefit from it. Okay, guys. Guys, I'm sorry I did not give you a break. We have just 20 minutes left. Would you like to continue with the architecture, or do you want to take a break here?
Maybe we can continue.
Okay.
Because almost it's only 20 minutes left.
Okay, guys, sorry, there is so much content, I forget, giving breaks. Really sorry. I mean, feel free to just stop me in between and ask for a break whenever you guys want it. Okay, guys, so let's get into the database architecture of Snowflake now. So it is, as we saw in the previous slide, it says it's a unique, unique multi-cluster, unique architecture, multi-cluster shared data. Okay, so we need to understand this. We need to understand what is the architecture of Snowflake. But you will realize the beauty of this only when you know what were the limitations in the earlier architectures. So for that, we need to revisit some traditional architectures in brief. Okay, so let's understand some traditional architectures. The very first among them was shared disk, shared storage, single cluster. Okay, so as the name suggests, there will be a centralized repository, which is this. Okay, and this will be shared with all your computing nodes. What do you mean by a node? Node is nothing but a computer or a machine or a commodity hardware, whatever you call it. It's a computing power. So all these three computers here on the top, they share this centralized repository, which is your storage. Okay, and what is a cluster? Single cluster. What is a cluster? You need to, it's a very simple thing. I mean, people sometimes get confused. Say these are my computers in here. Say and they call it as nodes also. Say I have 4 computers here. Okay, and they're all in one box. So these are my nodes. These all are my nodes basically. So my issues with paint continues. These are my nodes, and this whole box here is my cluster basically. This is my cluster. So if you see this is basically you can call it as 4-node cluster. 4-node cluster. And this is one single cluster. Okay, so I mean, you can have any number of nodes within this box. So that will, you will, in a general terms, you can say n-node cluster. Okay, so when we look at this here, it says a single node, single cluster. Okay, single cluster, that's what it says. So there'll be one big box, under that there'll be some machines, and that will be your computing power. So and all those nodes here, which I just drew in the paint also, that will be connected to a single storage. So this computer can process the data here also. This can process the data here. This can process the data sitting here. So they're sharing the data space. What are the issues? So there is limited scalability, guys. I mean, scalability means increasing the either increasing the storage or either increasing the compute nodes. Okay, so when you are trying to increase the storage, you again need to reconnect it back to all these nodes. And there will be a limitation up to some extent when you are sharing something, right? And even if you are increasing the nodes here, then also there'll be limitations up to where you can put pressure on your centralized repository. There's one issue there. And maintenance of data consistency across the cluster. Okay, so say this particular node here is working on, say, a particular set of data. Okay, it's updating that particular data here. This is my storage, say some storage data here, and some records it has processed. So this consistency means the current values of this data set needs to be provided to all the other nodes here. So obviously in a big system, it will not be a 4-node cluster or something like that. It will be huge, right? So that consistent or that data consistency or that metadata has to be provided to all these clusters here. So which is a maintenance bottleneck and expensive also. So communication with a shared disk is a bottleneck, because if I am working on a data set here, so basically I've locked that particular data set till I finish my processing here. So if any of my other nodes want to work on that data, I will have to wait for that. My other node will have to wait for that. So there is a big bottleneck in the communication. So as you can already see, parallel processing will not be able to happen here, right? So because, as I said, it will lock the data, whichever you are processing with that particular node. So already we are seeing so many issues here with shared disk architecture. So what they said, okay, let's come up with your shared nothing decentralized local storage single cluster. Okay, so guys, please remember they're still talking about single cluster only. Okay, so what they said, okay, so we will, so this is kind of data locality. This is also called as data locality. So here it was shared across the nodes in the cluster, right? So this was a global data for everyone. So here they made it local to that particular node. They said, okay, so some part of data here will be local to this node. This data will be local to this node. This data will be local to this node, and so on. This is, as you can see, it is achieving a massive level of parallel processing. So this is also called as MPP, isn't it? Massive parallel processing. This data set here will be working with this node only. So there'll be no bottleneck communication. Then there'll be no issues of locking the data sets and all that. So this overcame all the demerits of your shared disk, shared storage, single cluster. Okay, but it also had some issues. So as the data volume increases, the node also need to increase. What does that mean? So if this is my single cluster, guys, now we are talking about shared nothing architecture. Okay, so this is my single cluster. I have so many data nodes. Okay, if I draw on paint, it will take me years. So let me be content with 3 nodes, and I have data associated with them, data locality, as you can say. So if tomorrow I need more computing power, I need to add one more node here in the same cluster. Okay, but as you can see, data storage and compute is tightly coupled here. Tightly coupled means you cannot do one without the other. So if you are increasing this computing, you also need to increase storage, because who will you connect? Where will be the data locality be with? Because when you are adding a compute resource, it will not be able to work on this data, this data, this data, because these are local to their own respective nodes. So it has to have its own data, at the local level. So you will have to increase storage also whether you need it or not. And vice versa. If you want to increase storage, you will have to have a node associated with it. Because these are tightly coupled. So remember the word tightly coupled, guys. This is very important. So you increase one, you have to increase the other also. Okay. Due to this data locality, shared nothing architecture. Then data shuffling, it is a costly operation. So what is data shuffling? So say, there is a data set this particular node is working on here, node 1. And that data set needs to be accessed by this second node or third node or any other node. And that also needs to be worked on as per some business logic in this node. So this entire data has to be shuffled to this, because this node cannot contact with this because of the architecture design that we have created. You cannot do this. So this instead has to be entirely shuffled to the storage, to the other storage, or the storage that that particular node can work on. So this data shuffling is a very costly operation. Okay, so that's what it means. Then balance between compute and storage. So that's what we just said. They are tightly coupled. So we have to have a good capacity planning in place. That, okay, I will need so much of compute power and so much of storage, so that this costing can be balanced. Okay, remember guys, ultimately it's all about the cost. Then there is heterogeneous workload and homogeneous hardware. What does it mean? Heterogeneous means, guys, different things. So it says heterogeneous workload. So here, say on this particular node, my data loading happens always. There are different data sources and I have a ETL in between. I'm loading continuously data here, maybe through a batch or something. So this node is reserved for that. This node is, say, reserved for my QA stuff, my testing stuff. This node is, say, I have planned it in such a way that this will do only the reporting part. I have planned it in such a way. Okay. So as you can see, these are all different works, right? I mean, they are different operations. So this is your data loading. This is your data loading. This is your testing. Okay. And this is, say, your reporting. So these are all different operations, right? So this is what is your heterogeneous workload. What is that? That is what they're saying. But in a cluster, when you have nodes, they have to be of same configuration. That is why it is called as a cluster. So if this is 32 GB RAM, this will be 32 GB RAM, and so on. So, but my QA needs might not require 32 GB RAM or 100 GB of storage, or say 5 core of CPU processors. It might not need that much, but I'm bound by this. I cannot help it. So I have to give a similar configuration of this data loading node. So that is what it means by heterogeneous workload, homogeneous hardware. Then membership charges as per elasticity. So whenever you increase your nodes here, or computing power or storage power, so the person or the organization, say Oracle or other providers, they will charge you with some different membership fees, right? Say for 10 nodes, they had some slab or some billing model. For 15 nodes, they will have some other billing model. And you're bound by it. So in future, if you don't need them, or your workload decreases on that point, you are still stuck in that contract, maybe for a year or something. And as you know, those folks are billing on a very high high rates. So you are trapped there. You cannot. There's a lock-in period. You cannot come out of it till that specified contract ends. It's patching and upgrading issues. So if I want to patch something on one node, it's not possible on one node. It has to be, across the nodes. If you want to upgrade one node, it has to be across the nodes. So as your size or scalability here increases, you will have your upgradation, maintenance, patching, all that will also, be a bottleneck in terms of management and in terms of downtime and all that. So these were some issues in the previous architectures, shared nothing. So this is a shared nothing single cluster architecture, and previously we saw a shared disk single cluster architecture. So although this architecture shared nothing overcame the demerits of your shared architecture, but it came up with its own problems here. Although this gives you a lot of massive parallel processing, but these all costing issues, scalability issues, all that stuff is here. So performance is not a problem, guys, here. Performance is a problem in shared disk architecture. Okay, so performance is an issue here. Here performance is not an issue. Here the scalability, and costing and all that stuff is an issue. Okay, so now what Snowflake did, it said, okay, I will use a hybrid model which will have traits of shared disk also, shared nothing also, and I will take the best of both. For costing purpose, I will take the shared disk approach, and for performance purpose, I will take the traditional architecture, this shared nothing approach. So which is why it came up with multi-cluster shared data. Okay, if you see here, till here it is all single cluster. Now you see this multi-cluster. Okay, multi-cluster and shared data, centralized repository, so same like shared disk. Centralized scale out storage, multiple independent compute clusters. Okay, so what it means basically, firstly, when they say multi-cluster, it means this is your one cluster. So in the Snowflake architecture, you can have multi-clusters. Guys, just give me 10 minutes more. I will explain this quickly, this architecture today, and then we will call it a day. Okay. So this is your multi-cluster. Let's you can have more clusters here. So let's just stick with 2 for the time being. So what Snowflake says, I will have multi-cluster, and what it says about the storage, it will be a shared storage. So this is my storage, and I can have a lot of database objects in here. It could be tables, it could be views, it could be my procedures, whatever. And this will be shared with my cluster, multi-cluster. This is what it says, multi-cluster shared data, right? What else does it say? It says scale out storage, multiple independent compute clusters. In the traditional architecture of shared nothing, decentralized single cluster, there was data locality. Okay, right? So this particular storage will only work with this node here. But here there is that data locality issue has gone. This is available to all the multi-clusters here. Whatever number of multi-clusters will be here. This particular data storage will be available to all of them. Okay, plus this, so that tightly coupled issue is gone, right? So that tightly coupled issue is gone. So tomorrow, so we have 2 clusters right now. Tomorrow, if I need one more cluster, say of what, 2 nodes maybe. I need one more cluster for my computing power, 2 nodes. And as I have a shared multi-cluster architecture, I simply has to get a new cluster of nodes, and I don't have to increase the storage. which is why it is called as loosely coupled. Okay. And if this cluster, this is C1, this is C2, this is C3, they're all independent of each other. They are not bothered about their configurations. So the kind of nodes here don't have to be similar configuration here for this cluster. Neither they have to be similar configuration of this cluster. Obviously, the nodes within that cluster will have to be of similar configurations. But for the different clusters, they are not bothered about each other because they are independent of each other. So I can have a 32 GB RAM nodes here. I can have a 8 GB RAM nodes here. I can have a 16 GB RAM nodes cluster here, RAM here. 16 GB RAM nodes cluster here. I can have 5 nodes here in this cluster. I can just have 2 nodes here. I can have 10 nodes in this cluster. I can tomorrow, if there's 4 nodes here, say I want to within the same. So this was another cluster altogether that we added an entirely new computing resource. Okay. But say I want to resize this particular existing cluster only, say the C2. I want to add, say, 2 more nodes here. 1, 2. That also is possible. It's not affecting any other cluster here. Neither it is letting or forcing you to increase storage here. That is also possible. So see, so many advantages. So that is what it says by multi-cluster shared data, centralized scale-out storage, multiple independent compute clusters.
Hey, Abdul, one question. If I want to increase the storage, how it works?
Yeah, that is Arumugam.
Yes.
Okay. So as I said, these are loosely coupled. Okay. In case of traditional shared nothing, if you wanted to increase storage, you will have to have a node associated with it. So since this is since this is loosely coupled, I can increase the capacity here also. This I can increase this, and this will be automatically tied to my independent compute clusters. I don't have to do any changes in my clusters here, compute clusters. So these are called as compute clusters also, guys, because this is where the computing power is coming from. Okay, so there's no impact on this area here as far as the computing is concerned. They are independently scalable. Up or down, doesn't matter. Okay, guys. So this is a typical architecture of Snowflake. So see the huge number of advantages it has come up with.
Abdul, I have a doubt actually.
Yeah.
This is
Yeah.
Venkat, Abdul.
Yeah.
So my understanding is that so you have a centralized one, what your circle that will have a data of like for example finance, it may be a sales or employee data. It will create a virtual. They will create a virtual clusters. Maybe one cluster they may be used for the US region, another may be for an India region. So for the computational fastage. So whenever data comes back, it will come and update in this centralized one.
Yes.
That's my understanding.
Yes.
Right.
Yes. Whether this cluster is in the US region or whether this cluster is in any other region, they will come back and work on the same storage here only.
Okay. So they are splitting into different area wherever I need. I'll make use of this cluster to the region way so that I'll make a virtual memory. So my computation will be faster in Snowflakes.
Absolutely. So look at this. This is your tightly coupled. Okay. So we had talked about one demerit, which was heterogeneous workload and homogeneous hardware, right? We talked about that. So since this is a single cluster, all my node configurations are same. My data loading might require a high-end configuration or medium-end configuration. My QA might need less. My data science might need a very high, but I have to have the same configurations here. But when you come to the architecture here now, suppose this cluster, I have said, okay, you will be doing data loading process. This cluster, you will be doing, say, QA stuff. Oh, no, let's say data science stuff. And say this third cluster will say, okay, you guys will be doing QA stuff, testing stuff. So I need a very high-end computing power here. So I will give all of them 32 GB RAM, okay, and give them a lot of computing nodes within this cluster. For the data loading here, that C1, I will say you don't need much. 16 GB is enough for you guys, or maybe, yeah, 16 GB is enough for you guys. And I think 4 nodes are enough. So I'll give you this much. And for you, QA guys, maybe 8 GB is enough and 2 nodes are enough. I'll give you this much. It was not possible here because it was all tightly coupled. So this is one of the biggest advantages of scaling your resources as per your operation. So these are all heterogeneous workloads, right? Data loading, data science operations, and QA operations. So these are all your heterogeneous workloads. And now I have heterogeneous hardware also. There is no more homogeneous hardware now. As per the operation, I have designed my computes. So does that answer your question, Venkat?
Yes, Abdul.
So I hope you're understanding the beauty of this architecture already. I mean, the kind of advantages it brings with the kind of scalability you can do without affecting each other. Okay. So this is a high level multi-cluster shared disk architecture of Snowflake. So we'll do a deep dive. Yeah.
Abdul, one question.
Yeah.
See, the cluster C1, C2, C3, all three clusters are using the shared storage, right? So if one cluster is updating or inserting a data into the storage, should the other clusters will also be waiting to update that, or can be done in parallel?
Okay, very nice. So I am sharing this, but my operations are different for each cluster. So if this is related to my finance, it might be working on finance database. If this is, say, related to loading, so it will just be loading my databases. So there is very minimum chance that they will cross paths because I have segregated them on the operation basis. Okay, so it will most of the time 90% not do it, but if at all there is a what do you say, if they cross path, right? So the asset properties of databases will come into picture. So that data set will be definitely locked by the warehouse that is being processed.
Okay.
Yeah.
Abdul, do you have the fault tolerance also? No, over here, right? In this
Yes,
architecture, in
yes,
case of
yes.
no any data loss. Okay.
Absolutely. So this is all okay, guys. Now, okay. So I think we are over time. I will wind up in 10 minutes. Just I will want to ask you guys questions. Let me pick up one person. Okay, so Vinod, tell me, where is this Snowflake can be hosted, on what clouds?
On AWS, GCP, or Azure, any of them.
Awesome. So this means this is my compute power here, this cluster with nodes, and this is my storage power here, which I am going to leverage from AWS, if we assume that it is hosted on AWS. So we already saw on AWS, we have quite a few services under compute, which is EC2, and under storage, we have S3. So Snowflake, behind the scenes, for the computing power, uses EC2. So these are nothing but your EC2 machines. Okay, these are nothing but EC2 machines as far as AWS is concerned. If it is Azure, it will be Azure virtual machines. Okay, whatever services they provide as per their norms. And as far as storage is concerned on AWS, it uses S3 behind the scenes. Okay, so when whatever data you are storing here in Snowflake, when you log into Snowflake, you say you store some data in some tables. So behind the scenes, that data is basically being stored on S3, and say my data loading process is being happening through some cluster here. So behind the scenes, that computing power is coming in the form of EC2. Okay, so guys, remember this. As far as AWS is concerned, the architecture of the Snowflake remains the same. This architecture is not changing. Only the services are being changed as per the cloud provider you have hosted on. So somebody has asked me, I think it was Shiva, like, can we see behind the scenes, what services are being used? So Shiva, to answer you, as far as AWS is concerned, for computing powers, they use EC2. For storage, they used S3, similar to what Netflix also uses. And which S3 bucket, which EC2 machines, we don't get to see that. Which is why, guys, we had come across one point. Okay, I'm going to open that slide and I will end it there. We had come across one slide here. Okay, so I said they use EC2 power for computing and they use storage for S3, right? So, and they hide all the background stuff, which EC2, which S3, not our concern. So which point are they covering here? So I want to ask Shiva.
Sorry, Abdul. Which point means I understand the question.
So out of these 4 points here,
Uh-huh.
which aspect is that covering? When I don't know, or I don't have to worry about what EC2, what S3 bucket they are using. All
Minimal
I need
management.
Absolutely.
Minimal management.
Absolutely.
Still, yeah. Still, that is why I questioned. I have still some question, right, Abdul. For example, I have the data. The data what I store in the cloud is I'm storing from the US location, US geography location. If you say US availability zone, right? But the data is only frequently used by my UK boss, right? So when my UK boss wanted to access the data, he has to access from UK availability zone. The latency of data travels between the network between UK US, right? It will be physically travel through the network, even though if it is AWS network. So the latency will be more, right? So in this case, I don't have any control. That is what I'm wondering how Snowflake is going to is managing that.
Very nice question. Okay, so guys, we will wrap up after this. I can keep going on. I have so much content, but I'm sorry, I have to take this question, and after that we'll wrap up. Okay, before I answer, Shiva, any questions related to these topics that we discussed today, architecture or whatever, sometime back we discussed? I will answer Shiva's question in some time. Anything related to this? Any confusion? Any doubts?
Maybe Abdul, I asked one question. No, if we are using these snowflakes, if I am inserting the data, it comes directly to S3 or it goes directly into snowflakes. If you want, you can take in
Okay.
Express also.
No. This is fine. So it's okay. It's relevant here. So behind the scenes, as I said, it is using S3 bucket. Okay. So whatever data you manipulate here, it ultimately is in S3. It's residing in S3. This is the physical storage. So understand the philosophy of Snowflake. Behind the scenes, this architecture is a logical architecture. Okay. They have designed, okay, this will be the way I will be using my computing resource. This will be the way my data will be shared with the computing resource. But behind the scenes, all these services are the one in the cloud. So whether you insert data, whether you update data, whatever you do here, it will be behind the scenes in the service that you're using, and the service that you're using for storage is S3. So all your data will actually be residing in S3. But on the logical side, you will be seeing it in the form of tables here. When you log into Snowflake, you will say select star from employees. So you will see employee data here. But that employees data is being showed to you in form of tables, but it is actually behind the scenes stored in S3 bucket somewhere. So if you say update one new record in employees, so that will go to S3 only behind the scenes. But when you are seeing it, you're seeing it as in the form of a table. Understood?
Okay, okay. Then for example, if I am going out of the cloud from AWS, then I need to contact the AWS team only for the data migration, right? It will not
From where
reset
you
my
want to
data. Will
migrate?
not. Maybe for example, I'm using today Snowflakes.
Mhm.
Okay, so I'm going out of from cloud to on-premise. So basically, the data migration need to be done from the S3 to the on-premise.
Right. So
So basically, whatever the physical data that will be stored in the S3, maybe that data integration might be in the Snowflakes, but
yeah,
I got it that the data will be sitting permanently in the S3.
absolutely. So data will be
So
in S3. Yeah.
from S3, I can use the different like Redshift, whatever the data, whatever the front-end tool I want to, I can query and take the data. Right.
You will not query S3. You will query the table in Snowflake, because you will not know at all where S3, which S3 bucket they are storing. So
Okay.
if this is, say, if this is your Snowflake, there is, say, this table is there inside select star from employees. Behind the scenes, it is actually being stored with S3, which is permanent, but logically it's showing you in the form of a table, right? So actually there's nothing, there's no physical storage of table when you are storing it in your hard disks, right? It is actually a file. So, but when you show it on the screen on your databases, you show it as logical form of tables, rows and columns. So this is S3 permanent. So if tomorrow my Amazon wants to, say, access your Amazon Redshift wants to access my employees' data, it will not say, give me your S3 details. I will directly do it from there. You will have to give access to this table here, and it will do a select star from employees on Snowflake from their database. That's how it will work.
Okay.
And if you want to shift to, say, on-premise from Snowflake to Oracle, so you can always have some ETL tool in between. You can connect to Snowflake, and you can choose your data source as a table employee. You can have your endpoint Oracle as on-premise, and table data will directly go to Oracle data. In between, you can have a ETL tool. You don't need to know S3 locations to migrate your data from Snowflake to any other database for that matter. All you need to do is query the tables here. That's it.
Okay. I got it up.
Okay. So as I said, behind the scenes, what services they're using, you just need to know for your knowledge, EC2 machine and S3, but you don't have any whatsoever, right or access to them. You don't have any access to them. You can't do anything as a Snowflake user. It's all between Snowflake as a company and AWS. It's not your headache at all. That is why minimal management. Whether it has to be highly available, whether it has to be readily available, scalable at any point, you just have to say, scale it up. That's it. Don't have to go to this Amazon website here. Okay. You don't have to go here. Okay. I want to launch one more EC2 instance and let me launch it and then connect it with Snowflake. No, you just tell to Snowflake, I want to increase my cluster here. I want to add one more node here for my cluster one. That's it. It's Snowflake's headache to contact with EC2 and procure the EC2, contact AWS, procure a new EC2 instance and give it to you. Okay, so minimal management. Any other questions, guys, related to this before I finally answer Shiva's question? Okay, no, fine. So say what Shiva is saying, I have a data set here of finance. Let's consider this is a data set of finance. And this is sitting in my US region. Okay. And there is a team or say, business decision makers or managers or CEOs sitting in UK, and they want to access this data sitting in US from UK to US basically. So obviously there will be a lot of network latency because this data has to physically travel. There will be so much of latency. That's very true. So, so Shiva, the answer lies in this 4 points. Would you like to take a guess?
I don't fit any one of these 4 on my question.
Okay, so this is your instant live data sharing. Okay, instant. You can share your data instantly with any account and with any region there. Here, you will create there's something called as data share. You will create a data share. Okay, and you can immediately start sharing your data, you can immediately start sharing your data with this particular system here. And there is a separate topic on data sharing, completely separate topic on data sharing, which we will, there's a accounts, there's a consumer account, there's a reader's account.
I understand. My question is where to share, right? I don't know where my cloud is, where my storage is, right? In this case, where I would share the data.
So
you tell, yeah. My question is how to avoid latency.
Yeah. Okay. So there are various ways. I mean, when we come to the advanced topics of replications and zero copy cloning and data sharing, then that will answer your question there. Okay. So you have this topics in the course, right? Yeah. So you have this sharing of data in Snowflake, right? And there is a cloning topic also somewhere here. I'm not sure where. So there's a zero copy cloning, then there is replication and all that stuff. That will answer your questions.
Okay.
So basically it's the data sharing which you can do instantly with any other account. So what happens basically, just to give you an understanding on high level, if this particular data is there, it automatically creates another database here. I mean, it's not exactly database, but it creates a data share and copies all the metadata required for accessing your data. So which makes it faster access.
Okay. Yeah, I think we can park this question. We'll discuss when we go to this data sharing concept.
Yeah. Data sharing, zero copy cloning. There's inter-region data transfer also. All that stuff is there. Okay, so when we do pricing, when we learn about the pricing also, there will be something called as region data transfer, where you can transfer your data also. So
maybe the region plays a role here.
Yes. So there are various ways. I mean, you can avoid this stuff. But yes, to answer your question, one is your region data transfer. That comes for some price. So that will be covered in the Snowflake pricing.
Yeah.
Okay. So
I understand that tolerance, fault tolerance, everything will be the Snowflake will leverage AWS fault tolerance, data replication, those steps in the beginning. Yeah, I would be able to imagine that, right? But this case, I was trying to correlate how this, because one of my client, right, the latency has become a big issue now. Right, we started instead of having a big instances in a single AZ, we started having provisioning data instances, small instances in multiple AZs to facilitate avoid this latency. Right.
Okay.
That is what I was thinking. How the Snowflake will benefit the particular use cases. See, for example, the CloudFront was introduced recently to avoid the latency issue only, right? So when Netflix wanted to access the control, they introduced CDN network across the globe to avoid the latency issues.
Correct.
Right. So that is what I was trying to correlate how this latency will be effectively handled. Yeah.
Okay.
The multi-region and all, hope it will help in the future to understand that.
Yes, definitely. There is something called as data transfer, which comes with a cost. Okay, so there's a whole chart of pricing which Snowflake has given. So once we come to that part, definitely I'll show you that.
Sure, thank you.
So, okay, guys, we'll call it a day, and uh, please go through the recordings. The people who joined today, please go through recordings of yesterday's class. You have one whole week. Just brush up these things, and then we will do a little more deep dive next week on the architecture stuff, and then we will create our Snowflake accounts, and then we'll take some practicals from there onwards. Okay, guys. So thank you and have a good week ahead.
I will just start here.
So, Aramugam, yes,
Hello.
yes, Aramugam. Yes.
Abdul, yeah, I need syllabus. Is it possible to share the syllabus?
Yeah, it's possible. You did not ask Tamil Bhumi folks to give you that?
No, they just told me to contact you regarding that.
Okay, no problem. I will give it to you.
Thank you.
Just
Thank you so
ping me on
much.
WhatsApp separately. I will.
Sure.
Give it.
I will do that.
Oh, okay, or
Thank you.
I can give it in the group also, not a problem.
Yeah, fine. Both will work. Thank you.
Okay, guys. Okay. Thank you, guys, and have a good day ahead, all of you. Good week ahead, in fact.
Thanks, Abdul.